Меня зовут Sebastian. Я работаю в качестве евангелиста программного обеспечения для IBM. И я учу русский, но я плохо говорю, so I think it's easier if I talk in English. Okay? So, yeah, welcome to the session on enterprise testing and how to make enterprise testing more joyful. So I have a question for you. Who of you likes to test? Hands up. Oh, wow. Okay, so you're in the wrong session because you already, you enjoy testing, that's good, and you can go home. Okay, so about how to make testing more joyful and to fight these things where testing is actually not that joyful. So about myself, I work for this company called IBM, and I'm usually on the enterprise Java side, and testing is a topic that's close to my heart because when I go into enterprise projects, I see that there's a lot of room for improvement on how to do testing, and especially how to write tests efficiently, and especially how to write them in a maintainable way, right? Because what happens, we write some tests, hopefully, right? We write some tests, yeah. And then what happens, well, there's some change, there's some new feature, we do some refactoring, and then we have 100 failing test classes, right? So they don't compile anymore, and what we do, well, of course, we throw them away, or ignore, disable, and then, that's too bad, no tests anymore. So also what I want to show you, if I look at conference talks and especially articles, sometimes there's a huge difference whether you look into simple Hello World examples that show you how to use some technologies, or if you look into projects, like real-world projects, especially once they get more complex, it's, well, difficult because then you have to take other things into account. So this is why some info about myself. There's another important information. Ja lubię coffee. So that is why I have a coffee shop example. And I have one example application that is at least complex enough to show you some, well, more sophisticated example, not just Hello World, right? So we have a coffee shop here that a user can interact with, where we order some coffee, and that at least already includes some persistence. We have a database, and also we will have an external system, a barista backend. So this friendly barista person who brews your coffee. And that communication, just to make it more interesting, is done in an asynchronous way. So then at least we have some flow and some communication already going on. So I don't like slides too much, so I will just dive into the code right now. That is a Java Enterprise project, or Jakarta project. By the way, if you're interested in Jakarta and some other technologies, I have some stickers for you that you can grab at the end. That is called Coffee Shop. It uses Jakarta EE API. And just because I'm brave, it uses JDK 12. Who of you uses JDK 12 in production? Oh, nice. Oh, some brave. Who of you uses Java 13? Nobody? Okay. Who of you uses Java 9, 10, or 11? Oh, wow, that's good. And the rest, I guess, Java 8? Yeah, okay, awesome. Anyway, you can try that out if you like. And the project that I have here I will test it out locally just to show you what it does in a local way. So let's start this up, and then I will quickly walk you through the code. So I will just build this in my command line real quick, and then I run it. Locally, I run it using Docker containers. So that is quite easy, and that's a good way of abstraction to set that up locally. So I can run some things on my local computer that's easy to test, and then I just run 3 containers that I can see here. Docker PS shows me 3 containers. Let's make this bigger. I have a Barista system, that is the Barista backend. I have a Postgres, a database, and I have my application. So mostly now in the session, what I want to do, I want to test this coffee shop system. And first of all, I want to show you what it does. So let's quickly walk through the code. I mean, the most interesting use case is to order a coffee. So I will communicate with the system using REST, using HTTP. So you might have seen this syntax before. That's called JAX-RS for RESTful web services, right? If you're using Spring, it's very similar to Spring REST controllers. You have some annotations where you just annotate which URL you have /orders. And then you can do something like HTTP get to get me the orders, HTTP post to post the orders, for example, to create a new coffee order, right? And then what it does, I use some business component that is called coffee shop, some class, where I just create that order. And in this case, it does not much. It simply stores the whole thing in a database using a repository here, and that's it, right? So I order something, it stores it in a database, and then later on, in an asynchronous process, this will be sent to the barista. OK, good. Now let's try this out. I can communicate using, for example, curl or a browser or any HTTP client, right? It doesn't matter. That's technology agnostic. So I can say something like curl localhost. That's going to be mapped to port 8009, OK, whatever. The application is called coffee shop, resources orders, where I can say, OK, please HTTP get this. And what I get is an empty JSON array, right? No orders in the system yet. OK, in order to change that, you saw it's an HTTP post with some JSON. So let's do this. We can post something here. We can post some application JSON that might be, the coffee order. So let's have a look what an order looks like. An order is here. It has a coffee type. It has an origin. So if you go to a nicer coffee shop, you can order an espresso. You can order a cappuccino, something like this. And in a really good coffee shop, you can sometimes select the beans, right? Whether you want beans from Ethiopia, from Colombia, for another exotic country. So let's do this. I want to have a coffee, let's say an espresso. And I want a coffee I like coffee from Colombia. So let's post this, and then I post this coffee order to the system. And if I'm lucky, it says, oh, great, 201 created. That's good news. And my coffee is in the system here under this location. So let's have a look again. And I see, oh, yeah, there is a coffee here. OK. Работает, right? Works. Looks good. OK. And also, by the way, I already see some status. So this says collected. So there is some status going on when I order the coffee. First, actually, will say preparing, and then it will be finished at some point. And just because I wasn't fast enough, let's make this quicker. I immediately ask, and then this is now the status update happening. At first, it will be preparing, then finished, and then it will be collected. So this is now the communication that happens between these two systems. After a while, it will be sent to the barista, and that updates the status. OK. Now it works, right? Looks good, right? Ready for production. I mean, I just tested it. But what did I do? I tested it manually. I used the API. I went there with curl or something else, and then I see, OK, this looks good. But of course, that's not the best approach, right? Because I tested it once, and nobody tells me whether in 2 weeks, when I change a lot of features, it still works. I have no regression, and I have no automation being built in. So that's a nice start, but now I actually want to write some tests that test this. And this is why I want to start with that scope. I want to test this application now in a system test-like way, an end-to-end test, where I use the same boundaries, the same communication, HTTP, that a client would use later on. So I know from a black box end-to-end perspective whether that works. OK, so for that reason, I have actually a second project that is called coffeeshop-st for system test. Why it is a second project? Well, in order to not accidentally have some connection, some coupling with the code of the production code. So I want this to be totally external. I could actually use the command line. I can write bash scripts, right, to test my application, sure. I can use Python. I can use something else. And, well, in this case, I use Java because I'm a Java programmer. I use the same technology, JUnit, something like this, what I'll show you later on as well. And what I will do, well, I just write some system test here. Now, there's already a very important thing that I want to show you. So this is now why I write some very basic test. And now, at first, I want to write this test just in comments, just in like pseudocode, how I usually see tests being written in projects. So assuming now I want to test the same thing that I just did. Test create coffee order, right? I want to create a coffee, and I want to see whether that works. So what did I do? In order to create the coffee, I did something like HTTP post, right? HTTP post to, well, something orders, right? And if you remember, I posted some JSON, right? So then I do something like post some JSON, something like type. I just typed this here in pseudocode. Syntax doesn't matter. Origin Colombia, type espresso, origin Colombia. And now I post this, and then I want to verify whether the HTTP status is correct, right? So I say something like verify 201 created, right? So then, if that is the case, if I send this code, then I know, OK, the coffee has been created. And now I also want to verify whether it has been stored correctly, right? So we know there is some database being involved here. So if it stores, well, then later on I want to go to the system and retrieve the coffee again to see, okay, did it actually work? So in this case, then I say, okay, HTTP get something like orders. Well, how do I know the address? Well, that is the order ID. If you paid attention, I have something like an HTTP location header, and that tells me, let's say this, assuming should be the order ID, and then I go to orders order ID, something like this, where I HTTP get the information of my coffee order. And then I can say, okay, please verify whether this is, whether it has espresso with Colombia or something like this. Right? Okay. Then what else? I can verify 201 OK. Can verify that JSON, parse JSON or whatever. This is now just pseudocode, but that's basically it, right? This is how I would write my system test. Who has seen system tests like that? I mean, this is just pseudocode, but basically in that same manner that you have one test component, one test class, where you just write, HTTP client call and then verify, have an HTTP status, map the JSON. Okay, who thinks that's a good idea? Yeah. So what happens? Let's have a look at that. I could run this, and then basically I have this test here in that way. And then, of course, next week I say, okay, now we not only have espresso, we also have cappuccino. So what happens? Well, of course, you go to your test that you or your colleague wrote, you copy-paste the whole thing and say, oh, now the method needs to be renamed. Okay, cappuccino. Test create coffee order cappuccino, and this is coffee order espresso. And then you go here and have a close look of saying, oh, yeah, there's an espresso here, cappuccino. And maybe down there, and oh yeah, cappuccino. And then you can change the test, right? And then, of course, the week afterwards, you implement not only coffee from Colombia, but maybe Ethiopia, and then you go ahead and copy-paste the whole thing again, and you see this doesn't end well, right? And it's not only that. You also see, is this readable? Do you look at the test and you understand what you're actually testing, what you're doing? I mean, you see, oh, we do some HTTP posts, whatever that means, and we have some JSON, okay, whatever, and then we have some other JSON, we HTTP get another resource, but you don't actually understand the semantic or the motivation behind this thing. Now, another question, what happens if we change HTTP to something else, or JSON to something else? Well, then you're screwed, right? Then you can throw away the test class and rewrite it from scratch. That's faster. So let's remove this. And the reason why I'm showing you this in that way is basically, this is how I see most tests being created, and that is a very, very important thing to take into concern when you write your tests. You want to write a proper abstraction and use proper delegation. So instead of doing that, and I was showing similar things in my talk yesterday, what you should do is you care about the test scenario first, what you actually want to test from a domain perspective or from a tester's perspective, right? So what we actually want to test is something like create coffee order, right? We want to create a coffee order. I don't care about HTTP, I don't care about JSON, create coffee order. With espresso from Colombia, right? That is what I want to test. No HTTP, no nothing, no lower level detail, just that perspective. And then afterwards, I want to say, okay, please verify whether the order is in the system. Verify order with ID. Oh God, I cannot type anymore. With order ID. Then I know, okay, now I need an order ID. Well, then do something like save order ID before, wherever that comes from, some identifier from that coffee order. And now verify whether that order ID has espresso from Colombia. And that's it. That's what I want to test from a very abstract perspective. Now what I should do is I should introduce delegation, and I should delegate to a private method, or better, a private class, another class, how that is implemented, how I create my coffee, how I verify that. So let me show you another test. Looks like this. Now that is the same test class, basically, the same test method, create, verify, order. And now you see it's a little bit more readable, I hope. What we say here, new order, espresso Colombia. And then I have a component that is called coffee order system, create order. Okay. How it is created, I don't know. You don't see anything about HTTP here, you don't see JSON, you just say create order, whatever that means. And then you go further and say, okay, coffee order system, now please get me the order, using some identifier. And now assert that the order has a certain, well, properties, that the order is, espresso from Colombia. And now also assert that the number of all orders in the system, if you query that, contains my new order. So that the order is in the system, literally, and has the correct information, right? Now that is much more readable. You actually understand what you're doing. You actually understand what you're testing. Now imagine if that changes in the test scenario, if you say, okay, let's change espresso to something else, or let's add a new test scenario that tests cappuccino or Ethiopia, well, you can do that. It's very readable, and you immediately see what is happening. Now to the question, how is that implemented? Well, if we're interested, we have a look at that. That is a delegate I created, and that is also part of my test scope. That resides in the same test project. That is not forbidden to introduce, code quality. That's actually a good idea. So we can have a look at that, coffee order system, which in our case is just a basic HTTP client. But it allows us to define a nice abstract API to say, okay, how do you actually get the orders? Or how do you create an order? Well, that is now implemented here, and we say, oh, in order to do that, I don't know, let's send a request that constructs some JSON, we do an HTTP post for whatever URL, we verify that. So all of this lower level verification, like the HTTP status code, is also done in this component, in this delegate, and that layer of the abstraction. And everything else, well, offers just a clean API without leaking this abstraction. And that is very important because now what happens, well, we separated these concerns, separation of concerns. If you change something in the test scenario, well, you go here and you look it up here. And if you change something in the lower level details, like HTTP to something else, like JSON to something else, well, you only have to change it here. Now, in this Hello World-like example, this looks, not like a big improvement. But now imagine you have hundreds of test scenarios and different use cases. Now this becomes much, much more maintainable because then all of your different test classes can actually reuse that component, this class. So that is the important part. And then, well, this also runs quickly. Now, what I want to show you is the second thing. If we introduce some external system. Because that was just an HTTP client that goes to my system, creates something, comes back, and that's done. That is easy. Now it gets a little bit more interesting if we include another system, and especially if we have another system that we need to kind of change during the test scenario, or that includes some asynchronous communication. So now in this test scenario, what I want to do, I want to also test my Barista system. And now I want to test, well, the communication to that system. I don't want to test that system, right? I want to test my coffee shop. So in this case, what I do, I mock the Barista system. Same what you would do in unit tests, right? You use Mockito to mock components that are not interesting right now. I have one test object. In this case, that's this application. Everything else is mocked. If I want, I could also mock the database. And I can have some, HTTP mock server, like wire mock that replaces the system. And what I do then, in my system test scope, I use, well, control and verification mechanisms to tell my Barista mock how to behave, right? Now please respond in this way, now please respond in that way, and so on and so forth. How do we do this? Well, let's have a look at the second method. Create order check status update. So what does it do? It creates a coffee order, and now it checks whether the communication between these two systems is correct. And one system is mocked, right? So I say, okay, please create a new coffee order, espresso from Colombia, and now say, dear Barista system, and that's like a mock. Please answer for the coffee order that you will be, called with, where you get some communication in a second. Please answer for that very order with the following status. Because the Barista statement just updates the status. And once that is the case, then basically we go back to the coffee system and see, okay, now is the system, is the order in the system? Do we have the correct information? And then we say, okay, well, how do we know whether the communication occurred? Well, in this case, it's asynchronous. We have to wait, right? There is no better idea because it's not a synchronous request. If it would happen immediately, then we could, we would know whether it worked or not. But in this case, what we have to do, we basically say, oh, Barista system, that's now the mock. We wait for the invocation to happen. So we go to the Barista system and say, okay, please tell us once that is the case, once you have been called with the following order information, right? And then please get the order as well. Let's have a quick look how the Barista is implemented. It's very, very similar. It's basically also an HTTP client that uses wire mock. That is a mock server technology, where we basically can say, oh, for this URL, please respond accordingly, right? It's very much like Mockito, but on an application level. So we say, oh, in this case, please answer for the following order with the following status, which means if you get an HTTP post with the following request body, then return the following JSON. Okay. And later on, we say, oh, now please wait for the invocation to happen. In this case, we just have to do, a while loop with a timeout because that's the best we can do here. Or say, has the request been matched? So did you get an HTTP request with that following pattern? And then we can run this. Talking about running this, let's run that example where now I run this system test environment locally, where I run my application, and where I then run my Barista system in a mocked scenario. Okay, I have something set up here. I run some shell scripts that do this for me. So now, same story. I run 3 Docker containers. One will be the application. One will be the Barista mock server, right? I run wire mock. And one will be still the database. I could also run Liberty. I could also have an embedded database or something like that. But in this case, I actually don't care. I could just run the actual database. It depends what makes more sense for your scenario. And once that is up and running, I can show you how that system test works. So then we can walk through that actual system test. OK, now this is starting up. Run something else. So let's say, OK, curl, we can rerun the same thing again. I can get the coffee orders. And now, same story. It tells me, well, no order in the system because I just restarted it. And what I do now, I don't use the command line. I actually use my system test to create a coffee order. So let's run this. I run this test. And once my IDE woke up, it runs very, very quickly. I will come to efficient development workflows in a second. And now this, oh God, can you read it actually? This is kind of weird. No, not really. It says green. You have to believe me. That's a green test that just runs create verify order. It basically runs that method and says, OK, it worked. Good, whatever. That ran this method and just created a coffee. I can actually test that also on the command line. OK, now a coffee from Colombia is in the system. Looks good. Now, let's have the more interesting use case. Let's say now I want to connect to my system, and now I want to have this ping-pong communication between barista and coffee shop. So now I go to the coffee shop, I create the order, I tell the barista, hey, please respond in this and that way, and then it's also green. This now ran a little bit slower, but that's not the fault of the test case. That's the fault of, well, that's part of the business use case. Because the asynchronous communication is just not faster. It's actually a timer that runs every 1-2 seconds, and this will update my status. And now, the good news is I wrote this in an immutable way, or basically in an idempotent way. So I can actually rerun the tests, the 2 test cases, and I can rerun them again. And green, and it's green, and it runs quickly. So that is already a very important takeaway. I want to write my system tests or my end-to-end tests in a way that they execute quickly. Why? This test case, it does not fire up my application. I started my application before locally, and that's important because I start my application once, and the test is actually just an HTTP client or whatever communication you have. It's just a client that connects to my application and tests it in a black box way. So this runs really, really quickly. I can re-execute my test, and you saw it after 1 second, it's done. Now, what I also ran here is, well, a mode for Liberty. I use this Open Liberty application server that runs in, that comes with a nice feature that is a Liberty plugin. Wrong project. That comes with a Maven plugin here that allows a nice feature. It actually comes in a development mode where it changes, it looks for my file changes and will hot deploy the thing instantaneously. So if I, for example, let's go to some URL again. If I have a root resource where I see, okay, there is some, hypermedia links in JSON, whatever, and now I can actually change that on the fly immediately. This comes from another resource that is called root resource, and I have an entity builder here that builds my JSON response. Let's go into this. And it has a lot of code that builds up that JSON. And if I add something here, like, hello Kyiv, what it does, it immediately will redeploy and reload the whole thing and includes that change in my running application instantaneously. Why? Because it runs my application server in a mode where it just watches for these changes, and in less than a second, it updates it. So you don't have to restart, you don't even have to rebuild your project. It will listen for the file changes, compile the classes, and then move individual compiled classes to my running server. So if I change something here, it immediately has these changes there. If I say, Привет, instead of hi. It's really hard to type on a Cyrillic keyboard if you never learned it before, because every key is different. But I'm learning. Where is it? Here it is. You immediately see the update. So it changes instantly, within less than a second. And now that is the point of having effective development workflows. You don't want to wait, right? Why? Because programming is such a flow activity. You want to see that changes immediately, and you want to have that feedback immediately, right? So I really want to go into my code, I want to change something, and I want the update in my ideally running application locally seen right now, and then I want to be able to update my tests and re-execute them right now, so within less than 2 seconds I get an update, okay, whether it works or not. Why? Otherwise I just get distracted. And this is why a lot of tests are just not fun, just not joy to use, because I start up my tests and then it runs for, I don't know, how long does your Maven build take? If you run Maven or Gradle build without skipping the tests, how long does it take? More than 10 seconds? More than 1 minute? More than 5 minutes? Oh God, let's stop here. Too slow. Why? Because, again, programming is a flow activity where I want to be able to have immediate, instant feedback. Because what happens? We're humans. We get distracted. We get bored, right? So if I change something here and then I run my test, what happens? Well, I go to this here. I take my smartphone. I check Telegram, Instagram, whatever gram you have. You go to social media, you go to Slack, you check your emails, and then you're distracted, right? Because you have to wait 10 seconds, 20 seconds. Even waiting for 20 seconds, it's too slow. You get distracted. So I want this to happen immediately. And that's one of the most important takeaways here. I really care about my test runtimes. That's why I run my tests in this way. And you might say it looks very, very boring, and that's on purpose. It just is plain JUnit. This is JUnit 5. You can do the same with JUnit 4. Without any extension, without an additional runner. I'm not running any test integration framework or something like that. It's just plain JUnit. Why? It runs fast. If you run your integration tests, if you're in the Spring world, you might use Spring context tests, right? If you're in a Java Enterprise world, you might run things like Achillean or CDI unit. All of these things, they build up an embedded or simulated environment. They try to start your application in one way or the other, and then run your tests, which is nice because you can inject some code easily in your test class and do some stuff, but it's slow, right? If you have a single one, it starts in a few seconds if you're lucky, and then if you run that in default mode with multiple ones, well, it's 5 seconds each, right? And now in a more complex projects, you have 100 of these classes, and then you end up with build times like minutes. And from my experience, that's the biggest impact in build times and especially feedback cycles in real-world projects. So ideally, you run this in a way where you actually separate the life cycles from the test environment life cycles. This is what I'm doing here. I fire up my application before using shell scripts or using Docker Compose or using whatever you like. If you're cool, you can run Minikube or Minishift and have an OpenShift cluster on your laptop, whatever. But then during your test cycle, you just fire up your test that already connects against something that is already running. You don't want to start up something in your test cycle. That's too slow. OK, let's move on a little bit to code-level tests, right? So that was now a system test end-to-end environment. I could also swap the Barista from a mock to the actual Barista and run this. The only problem is then you end up with actual coffee, right? You create a lot of real coffee. So that depends on the environment that you test against. But now, on a project level, how does the project code look like? So this is the system test, but I also have test classes that are in the production code project. So let's say I have a simple unit test. So I don't want to talk too much about that because from experience you know how unit tests look like. The most important thing that I care about, it looks very, very boring without any additional test execution, just mostly programmatic test code with Mockito, with AssertJ. Why? Because it runs fast. Now, the problem with unit tests in general is your unit, typically a class, is tested as a test object, and all of the other delegates, other communication is typically mocked away. The problem that you create here, you really nail down how your whole project is being set up and wired up. And what happens if you do some refactoring? Well, you get a lot of failed test compilation, right? And you can throw away your test classes. So same problem. So there is some code-level integration test technology that help you a little bit in that. You can run, a Killian test, Spring test that fire up, your beans and auto-wire beans. That is a little bit, helpful, a little bit better. But again, you end up with test execution times that just run slowly. It takes too long in a more complex projects. There are some workarounds where I can deploy it once and then reuse some kind of deployment. But my point is, these simulated environments are not very representative because they're always just simulations. They're not the actual application that you would run later on in production. So you would have to retest it anyway because your controllers or your resources might run differently. You might have a difference in JSON mapping. The configuration might be different. All these things that later on fail. So you have to test it in a proper end-to-end test fashion anyway in, for example, using the same Docker image that you run in production as well. So that is an important thing. However, there is some trade-off where, say, you can run some code-level test by still testing something with a smaller scope, but testing some integration. So this is, hope that's readable. This is something I also brought up in the book that I wrote about Java Enterprise, what in my book I called component tests, but I think a better name is use case tests. What I want to have is code-level integration tests that test the integration of multiple components, right, like multiple classes, the ones that are responsible for a single use case, for example. And I want them to run quickly, and I want them to be maintainable. So if I refactor something, that not the whole work breaks, right? What I do here, I actually run everything in a programmatic way. But for example, I have a class coffee shop and order processor. What I do, I introduce test doubles, TD, that extend my production code, the classes, in the test scope, where I can pre-set up wiring, mocking, verification, so just that my code is more maintainable, that is more effective to use. Let me show you an example. I have my coffee shop here. That is a class that resides on my production scope, right? Has some dependencies and does some bunch of stuff. And now I have on my test scope what I call test double, coffee shop test double. That's in the test scope. What it does, it extends this class. And it adds, well, first of all, some wiring logic and also some verification or mocking behavior that is, again, now on a more higher level. that introduces some abstraction that I can reuse in my test classes. So what I create reusable components, so my test is actually easier to write. If I have the same for order processor test double, same story, it will already set up some wiring, and I can set up some verification that I otherwise have to introduce in every test class, right? And now what I do, I have a use case test that just uses these things. So that is my actual test. I say, I want to use the coffee shop and the order processor. These are just, my components. And that is simple to set up because all the logic happens again in the delegate. I just delegate all of that setting up logic. And that's my actual test class, my test method. That is simple. I just say, oh, new order, and now that is the business method that I'm testing, create order. That's my test. And then I say, okay, verify whether the order has been created, for example. And then this has the implementation that you saw, it says, oh, verify mock, entity manager, blah, 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 blah. And then, same here, process answer for unfinished orders. This can process it, and then it verifies on the order processor whether all of that works. But now you see, same story. The test cases are easy to write, easy to read, and easy to maintain. If something in your structure changes, like the communication between coffee shop and order class, order processor, then I only change them here again in the test double. That is easy to reuse. So same story, if I have 100 of test classes, I use the same delegation and, abstract, a separation of concerns to be a little bit more efficient here. The nice story is it's just JUnit with, plain programmatic Java, so it runs very, very quickly. And JUnit, plain JUnit is very fast. You can run hundreds of classes, hundreds of test cases in, milliseconds. And that is what we want, because the more complex our project gets, you can run, your stuff very, very quickly, and you don't have to wait. So these are the, more important things that we have here. The same, I can have some what I called smoke integration test. It's very, very similar to what I just had on the system test level. It just connects to an environment and just connects to an environment that is already running. Same what I had before. If, for some reason, you want to run this on the command line. So what I did, I executed all of that in my IDE. Also, this Liberty test plugin, which you might want to try out, can run your test if you hit enter, then run all of the unit tests and integration tests. You might have heard of the notation unit test and integration test. That is a Maven convention, right? You might see the difference. If I call something use case test, that is a unit test. Why? Well, it's called test, T-E-S-T at the end. That's a Maven convention, so then it will be executed by the Surefire Maven plugin. If I have an integration test, that is called IT at the end for integration test, then it will be executed by failsafe, right? So just stick to these conventions, that's actually the easiest. And then if I say Maven package or Maven test or Maven verify in my project, then what it does, oh, that's not my project, sorry. Coffee, should run this in the actual folder. Then it will just run my Surefire tests, Maven Surefire plugin. And apparently my computer is under load. That's a build time of 4 seconds. That's a little bit slow. It should be like 2 seconds or so, but better than 3 minutes. And if I would like to run my integration test, I run Maven failsafe integration test. That doesn't run, that's the second phase. That doesn't run my unit test. That only runs the Surefire test, the ITs. So that is, like my smoke test that goes against this environment here. I have a skip test here, that's funny. And, that is the life cycle. If you stick to that, then you basically, very easy to set up and you use your Maven conventions here. I think that makes a lot of sense. So the most important thing is just to stick to your conventions here and to care about all these life cycles and the reusability of these components. So as some takeaways here. The most important thing is the code quality of your tests, it matters. Most importantly, separation of concerns and building proper abstraction layers. Because then, regardless of the technology you use, you will come up with maintainable test code. That is the most important thing. So actually, I don't care which test framework or test technology you use, whether it's plain JUnit, whether you use some actual, other test runners, whether you use TestNG, whether you use not Java but Python or Node.js, whatever. It just, you want to care about the test code quality, and it has to run quickly. It really has to execute fast, so within a second, you want the feedback whether it works or not. And that is important, otherwise it's not effective to use that development workflow. As you saw before, I want to be able to change something on the code, have maybe a hot reload thingy running locally that reruns my application, and then I immediately want to execute the test that connect to that environment so I get immediate feedback whether it works or not. I don't want to wait even 10 seconds. That's too slow. So really care about this fast feedback. From experience, it helps a lot if you keep your test technology simple. Plain JUnit with a little bit of programmatic setup, that's okay. That is the easiest way to stay quickly, because then you don't have any reflection or magic going on that slows down your process. What is very helpful as well, separate the life cycles, the life cycle of your test from the life cycle of your test environment. So I do not want test classes that on every run set up stuff, because typically that's too slow. Who of you knows about test containers? It's also very interesting technology. I mean, I like the framework. It's a nice Java API, but I typically don't use it for the same reason. Test containers would set up the Docker containers on a Java API, which is really cool. It's helpful to write it in Java, but then it fires them up and each and every time you run your test. And then you have to wait 10 seconds for your Docker container to start up. And if you want the fast feedback, that's too slow. Actually, we're working with the test container folks to have containers that you set up once and then they keep running, and then it's more efficient and you can have a similar experience. But that is just important to separate these life cycles. And the easiest thing to do that is just to not tangle your tests with some other life cycle. So that's an important takeaway. Same reason why I typically don't use any integration test technology, Spring Test, Archillion, CDI unit. It's just easier to keep that separated in this way. Build up a local environment that you start up once. Once in the morning, you come into the office, you start up the thing, and then you can check social media for 5 minutes until it's up and running. You can get your coffee, and then you have a productive environment afterwards. Important as well that you build up idempotent test scenarios that you can reuse. So actually what I showed you in the coffee shop test, like this, you can take this test and run it not only against your local environment, but also against staging environment or some Kubernetes cluster, right? You just go to your coffee order system and set up some system properties on the command line maybe, like -d coffee shop test host, and change local host to something else, and then you run the same test against a Kubernetes cluster. That is now helpful because you separate these life cycles, so you can actually reuse these components. You can reuse the same code for all kind of performance tests, for any other test scenarios that you can reuse from another point, because you have these components that are reusable. And in the same thing, I believe it's much, much, much more important that you care about the test code quality rather than the test framework you use. Who of you uses Spark testing, like Groovy? A few. At least a while ago, there was quite a hype. A lot of people like this. Who of you use a Scala test or any other JVM language, Kotlin, to test? Yeah. Works. You can do that. But for me, it's more like an extra, like additional syntactic sugar if you care about a nicer syntactical sugar of how your test scenarios look. Because if I have a more complex project, then it's very important that you create proper delegates and introduce that code quality. And then that is such of an improvement. And maybe you can have the last small improvement if you swap JUnit to Spark testing if you like or not. But then again, it's a trade-off. You have another JVM language. You have to educate your team. You have to introduce that the build server supports Groovy or Scala or Kotlin or something like that. It's more effort, and then the question is, how much does it buy you? So I care a lot that you care about code quality. And in any way, even if you use the nicest test framework, if you have a complex project and if you don't care about code quality, then the best test framework won't help you. They won't necessarily make your tests more maintainable if it becomes more and more complex. So that's an important thing. What I sometimes use, who of you knows about Cucumber, like BDD testing and Gherkin syntax? So sometimes that can be helpful. I have something like this. It might be helpful if you deal a lot with non-technical business people, where you say, okay, they don't know about Java code, but they know, create a valid coffee order. If I create a coffee with espresso from Colombia, that should be accepted. That's valid. If I create an espresso from Germany, Germany doesn't have coffee, then it should be rejected, right? And things like that. And now this is, more readable for non-technical people. And then how do you implement it? Well, same story. You use reusable components in your step definitions and say, okay, what is create an order with this and that? Well, then you say new order, and now coffee order system, create order, get order, same story as before, right? It just adds you a little bit of extra. What I like about the Cucumber syntax is it forces you to stay on this abstraction level, right? Create coffee with espresso from Colombia. You don't talk about HTTP, you don't talk about JSON, you stay on this abstraction. That's important. If you want, you can have a parameterized example as well and things like that, or you can run parameterized JUnit tests. That's also very, very helpful if you have a lot of input and output. You can be very creative in what you test. The question is just it needs to run fast. So you can do that as well. That actually runs also quite quickly. I can run my Cucumber test. That is now ran a little bit differently. However, again, test code quality matters. And actually, I kid you not, I even had business people, like non-technical people, who were totally fine with reading that syntax, right? So if you compare this to where was it? To that. This is really human readable, right? It reads like a sentence. That's nice. But if you have, if you have business people who know about your domain, I had non-technical people who were totally fine with reading Java code, right? If you don't know the syntax, and it looks crazy, but if you ignore the syntax, just trying to be reasonable. If you say new order, espresso Colombia, well, you probably have a new order with espresso from Colombia. You might wonder about this weird brackets and that weird semicolon, but it reads like some words, right? If you say coffee order system, create order, well, it will probably create an order with espresso from Colombia, right? So the point is, if you craft proper readable APIs with a proper abstraction, then it's even readable to non-business people. And I had that before, that they were totally fine with reading or even editing that. That is more important rather than caring about some additional fancy test technology. So these are some important takeaways, and I hope this was helpful. And spasibo большое, and thank you very much for your attention.